Okay, I'm going to begin section 8.2 now. In this one, we're going to talk about linear inequalities and absolute value inequalities. Before we look at solving inequalities, we need to be familiar with what's called interval notation. We're going to use that a lot in this book, in this course. So I just want to get us, some practice using interval notation and then graphing a solution on the number line. In this one here, in part A, suppose that we wanted to represent all the numbers that are less than 3. Okay, well, if I'm less than 3, then I'm heading out towards the left, towards negative infinity. And so I'm going to write negative infinity comma 3 in that order, and I'm going to put parentheses at both ends. In general, you're going to use a parentheses if you're not including the number, and you're going to use a bracket if you are including the number. We'll look at several things with brackets, as we go forward. But the fact that I'm only representing the numbers that are strictly less than 3 and not less than or equal to 3 means that I want a parentheses by 3. If I were to graph this on the number line, here's my number line, and I've marked out 3. An open circle means that you're not going to include the number, and a closed circle means that you will include the number. So because I'm not including 3, but just strictly, all those numbers that are less than 3, I want an open circle there at 3. Anything less than 3 means I'll be shading towards the left on the number line. Part B, okay, let's use interval notation for all the numbers x that are greater than or equal to negative 7. Okay, well, if I'm greater than or equal to negative 7, I'm heading out towards the positive direction, towards infinity. So I'm going to write negative 7 comma infinity, and it's got to be in that order. And I'm going to put a bracket by negative 7 since I'm including that start point here with this being a greater than or equal to and not just a strictly greater than. I want a bracket. Again, a bracket means that you're including the number. Now, on the number line here, I've marked out negative 7, and I want a closed circle at that spot since I'm including my start point here. A closed circle means that you're including the number, and open circle means that you're not including the number. Okay. One thing about interval notation is that order matters. You always want the smaller quantity first, bigger quantity second. Okay, so if somebody were to write infinity comma negative 7 for this problem, like that wouldn't make any sense. Okay, because the smaller quantity isn't first as you scan this from left to right. So there is an order to using this notation here. By the way, also you will always have a parentheses by the infinity or the negative infinity symbols. Why not a bracket? Well, because infinity is not a number. Okay, and I mentioned that you're only using a bracket if you're including the number. Number is a key word. Okay, infinity is not a number. Infinity is just a symbol to show unboundedness in the positive direction. Okay, so since that's not actually a number, you're never going to have a bracket by the infinity sign. And same thing with the negative infinity sign. Those are not numbers. Okay. Part C. Okay, all the numbers between negative 1 and 3, including 3, written as an interval, would be what I have here, negative 1 comma 3. I'm including the right endpoint, so I'd want a bracket there. And I'm not including the left endpoint, so I'd want a parentheses over on the other side. On the number line, here I've marked out negative 1 and 3. And I want open circle at negative 1 since I'm not including that left endpoint, with that being a greater than sign. And then I am including 3 since I'm including that right endpoint there. Closed circle there at 3. Okay, anything between these two values means I want to be shading between the two circles there on the number line. Here's another one, part D. Okay, all the numbers x that are less than negative 5 or x is greater than 3/4. Or is a key word. I'll talk about that shortly here, but you're really describing two different groups. Okay, you're in this first group or this other group over here. Okay, so I'm going to be using two intervals when I write my, my interval notation here. Anything less than negative 5 means that you're heading towards the left, towards negative infinity. So I'm going to say negative infinity, comma, negative 5 in that order. Parentheses on both ends, since we're not including that start point there. Or 3/4 to infinity would be representing everything bigger than 3/4. Parentheses everywhere for this here. Okay. The union sign, which you'll see in the book on occasion, is this symbol here, and it's used to represent the word or. You can write the word or, it's only 2 letters, okay, or you can use the union sign here. They both mean the same thing, like I said. On the number line, I'm going to have 2 regions to shade, okay, because I mentioned that you're going to be either less than negative 5, so you're over here, or you're bigger than 3/4 means you're over on the other side. Okay, 2 different groups that don't overlap is what we're describing here in this problem. I want open circles there at my 2 start points, since I'm not including either one of these 2 start points here. Okay, and what we see on the number line then is that we're shooting off in different directions. Part E, we have all the values x that are not equal to negative 2. Okay, so I want to represent any number, just not negative 2. So anything less than negative 2 or anything bigger than negative 2 would be fine. Here's how I would write that using an interval notation. And then on my number line, here I've marked out negative 2. That's the one and only number that I'm not including, so I'd want an open circle there. And I would be shading everywhere else on the number line then. To represent all real numbers as an interval, you're going to write negative infinity to infinity. Parentheses at both ends. I mentioned that you'll never have a bracket by the infinity sign or negative infinity sign because those are not numbers. On the number line, you'd be shading all the numbers. They're all real numbers. Okay. We'll be using interval notation a lot in the book, for various things. So we want to make sure that we're good with that particular kind of notation. Now, when it comes to inequalities, they work very similar to what we see with equations, how, when we solve an inequality, we want to get x on one side and then the numbers on the other side. One huge difference, though, that we need to make sure that we note here is when we multiply or divide both sides of an inequality by a negative number, we must change the direction of the inequality, okay? Here's just 2 quick examples to show you why we are switching the sign. Suppose that I have the statement 1 is less than 2. Okay, that's a true statement, 1 is less than 2. If I multiply both sides of this inequality here by negative 1, 1 times negative 1 is negative 1, 2 times negative 1 is negative 2. Now, which is the bigger number? Well, it's going to be negative 1, right? So I got to switch the sign. Otherwise, if I left it alone, I wouldn't be saying a true statement. Negative 2 is not bigger than negative 1. Here's another example. Okay, so again, 1 is less than 2. That's a true statement. What if in this inequality I divide both sides by negative 2? 1 divided by negative 2 is negative 1/2. 2 divided by negative 2 is negative 1. Which side is the bigger side? Well, it's going to be negative 1/2, right? Negative 1/2 is bigger than negative 1, so I have to flip the sign, otherwise I'm not going to be saying something that's true. Okay. Bottom line, whenever you multiply or divide both sides of an inequality by a negative number, you got to make sure that you flip the sign. Now, that's a common mistake that algebra students will make. You got to make sure that you remember to do that. Let's get some practice solving inequalities now. Okay, so problem 4, I want to solve for x. We'll write each answer using interval notation, and then we'll also graph the solution on the number line. Part A, okay, so I want to solve 3x minus 5 less than 6 minus 2x. Well, if I, if I subtract 3x from both sides and then subtract 6 from both sides, negative 2x minus 3x is negative 5x, there on the right. And then I also mentioned that I'm subtracting 6 from both sides. Negative 5 minus 6 is negative 11 on the left. Divide by -5. Negative over negative is positive. Also, x will be all alone there on the right. And the fact that I just divided both sides by negative means I got to switch the sign there. Okay. Usually when we read a mathematical statement, we want to see x first, although you don't need to do that. You know, if what I have here works just fine. But as an interval, order matters. So basically, you know, anything less than 11/5 is going to be okay. It's going to make this statement be true. Anything that is 11/5 or bigger, we don't want that, because otherwise we're going to say something that's not true. Okay. So as an interval, anything less than 11/5 would be where I'm heading out towards the negative direction there, towards negative infinity. And so I'm going to say negative infinity to 11/5. I'm not including 11/5, so I want a parentheses actually on both ends here. Okay, and on the number line, open circle at 11/5. Since you're not including that number, anything less than that number means that you'd be shading towards the left. Part B is another one, same deal, solve for x. So in this one, I want to begin by distributing 3 into these two terms. I've done that. Combine your like terms here on the next step. And then let me subtract 3x from both sides, and then subtract 6 from both sides. So if I take -7x minus 3x, that would be -10x. Subtract 6 from both sides. -4 minus 6 is -10 on the right. Divide by -10, and again, since you're dividing by a negative, you got to make sure you flip the sign there. So in this problem, it looks like anything that is 1 or bigger is going to make this inequality be a true statement. Anything that is less than 1, we don't want that, because otherwise we're going to be saying something that's false. We're including our start point, right? So a bracket by 1 to infinity would be my interval notation here that I'd circle. And on the number line, closed circle at 1, since you're including the start point. Anything that is 1 or bigger means that you'd be shading towards the right. By the way, just a note here, like the way that we solved both of these, you don't, I mean, it's just one way. There's several ways that you can solve an inequality here. If I just go back to part A for just a moment, maybe an easier way to do this problem would be to add 2x to both sides and then add 5 to both sides, and then divide by 5. If I did that, there would be no sign flip. Okay, since you're dividing by 5, and 5 is a positive, not a negative. That would be an easier way to do this. Probably you still get the same answer. Okay. The only reason why I did it like this is just to kind of re-emphasize the whole flipping the sign thing, since again that's a common mistake that students will make, is that they'll forget to switch the sign. So be sure that you remember to do that when you're solving an inequality. Anytime you multiply or divide by a negative, you got to flip the sign. Okay, and I'm going to go ahead and stop the video here.